So now we're going to talk about graphing logarithmic functions. This is closely related to graphing exponential functions, not surprisingly, since these are inverses of exponential functions. So first we'll look at the graph of f of x equals b to the x with b greater than 1. That's the exponential function base b. It's exponential growth, where the base is larger than 1. And if we invert that, we reflect it across the line y equals x. And the line y equals 0 becomes the line x equals 0. Remember, finding the inverse function is just a matter of switching the x and y coordinates. So y equals 0 becomes x equals 0. And that point 0, 1 becomes 1, 0. The tail that went to the negative x-axis now goes to the negative y-axis. And it looks like that. So that's going to be, if f of x is b to the x, that f inverse of x is log base b of x. And the base is the same. So in this case, for these graphs, the base is greater than 1. Exponential growth and its associated logarithm. And now we're going to do the exponential decay one. So this is when the base is between 0 and 1, and its inverse function is log base b, where b is between 0 and 1, the same b as the original one, and that looks like that. So now notice exponential decay, the tail of the function is in the positive x-axis, and for log base b, I'm sorry, what did I say? F of x equals b to the x. The tail of the function is on the positive x-axis. And for the log base b of x with b between 0 and 1, the tail is in the positive y-axis. So it's kind of like when the base is larger than 1, the logarithm function is basically the same, but it looks like it's upside down. So the domain of log base b is 0 to infinity. Why? Because the range of the exponential function is 0 to infinity. And you could also tell by looking at the graph. Right? The domain is the values of x that you can plug into the function and still get a real number for an output. The range of log of b, you can see from the graph, is negative infinity to infinity. There's no asymptote up here, or I would have drawn it in, where this doesn't go above it. So it keeps going up forever. It just goes up very slowly. We say it goes up logarithmically. Okay, so transformations can be applied to logarithms, the same as with any relation. Okay, so like any other function, but even relations, you can do transformations. Right, so to graph a logarithmic function, first, we want to graph the vertical asymptote, then plot 3 points on the graph, and you want to choose your inputs so that the argument, the part that's plugged into the log base b, is a power of b, and that's because then the log base b and the b to the power, the exponential function base b will cancel, and you'll just get the exponent. And so I would use b to the -1, b to the 0, and b to the 1, just because it makes for nice points for your graph. It makes it easy to graph. And so we'll do an example on the next video.